Okay, Assalamualaikum warahmatullahi wabarakatuh and a very good day to everyone. Okay, so welcome back to our class. Okay, so today we're going to continue from what we have left yesterday. Okay, so yesterday you have learned about a lot of things. Okay, we stopped at where to find the range and interquartile range. Okay, so for today's lesson, okay, we're going to look at learning standard 8.2.1. Okay, which is calculate the mean, variance and standard deviation. Okay, so this example you can have a look later. Okay, so let's look at number one. Okay, first let's calculate the mean. Okay, so for mean, okay, usually we use this symbols. Okay, x bar. Okay, x bar is mean. The formula for x bar is summation of x divided by n. Okay, where n is total number of samples. Okay, so you have 5 plus 6 plus 7 plus 7 plus 3 plus 4 divided by how many items are there? 1 2 3 4 5 6. So divide by 6. Okay, so press your calculator, you will get 5.33. Okay, so next, okay, this is the first one. Okay, second one, we need to calculate the variance. Okay, so there are two formula for variance. Okay, so I'm going to use the first one. Okay, so variance, okay, the notation is sigma square is equals to summation of x square divided by n minus mean square. Okay, so how to write it? Okay, you need to write it this way. So each numbers you need to square it and sum all of it. Okay, so we have 5 square plus 6 square plus 7 square plus 7 square plus 3 square plus 4 square divide by total number is 6. There are 6 items minus mean. What is your mean? From previous question, 5.33, and then you square it. Okay, so press your calculator carefully. Okay, press your calculator and you will get 2.2578. Okay, and last one is standard deviation. Okay, so standard deviation, SD, or the symbols is sigma. Okay, you just simply square it the value of variance. Okay, so you will get 1.5026. Okay, okay, next let's try number 2. Okay, so the first one we need to calculate the mean. Okay, so mean x bar is equals to summation of x divided by n. Okay, so please make it a habit to write the formula. Okay, so we have 21 plus 24 plus 26 plus 19 plus 18 plus 27 plus 21 plus 20 divide by how many numbers are there? We have 8 numbers, 8. So press your calculator, okay, carefully. So the answer is 22. Okay, so next calculate the variance. Okay, sigma square, so summation of x square divided by n minus mean square. Okay, so we have 21 square plus 24 square plus 26 square plus 19 square plus 18 square plus 27 square plus 21 square plus 20 square divided by 8 minus the mean 22 square. Okay, so press your calculator carefully. So your answer is 9.5. Okay, and the last one is standard deviation. Just square root the value of variance. Okay, so you will get 3.0822. Okay, so that's it. Simple, right? Okay, so you can try yourself for number 3 and number 4. Okay, so actually there are method of using calculator for you to check your answer, where you just key in these values and then you press some more numbers and then you get directly the answer for means and deviation and variance. Okay, that method I will show you later. So for now we just use the manual calculation first. Okay, so let's move to F. Calculate the variance and standard deviation for each of the following frequency tables. Okay, now before previous question, you have a set of numbers, okay, ungrouped numbers, and then this section, okay, you also have ungrouped data. Okay, this is ungrouped, although it's inside the table, we still consider this as ungrouped data. Okay, but this data is put into the frequency tables. Okay, so how can we calculate the mean, variance and standard deviation? Okay, so look over here. Okay, so summation of, okay, over here you have summation of fx divided of summation of f, where f is actually the frequency of the table. Okay, in order to find the mean, you need to find the sum of frequency times the score. Okay, divide by the sum of the frequency. Okay, and over here for variance, okay, the formula is summation of fx square divided by summation of x minus mean square, where, okay, the first part is actually the sum of frequency times score square. Okay, not the frequency but the score. Okay, because usually students did a mistake over here. They squared the frequency, not the score, but you need to square the score x, not the frequency f. Okay, so let's do together question number 1. Okay, the first one, mean. Okay, mean x square equals to summation of fx divided by summation of f. So we need to times frequency and the score, then divide by summation of f. Okay, so we have frequency is 3, 4 plus 3, 5 plus 4, 6 plus 6, 7 plus 7, 8 plus 3, 9. So divide by total of frequency is 3 plus 3 plus 4 plus 6 plus 7 plus 3. Okay, press your calculator carefully. Okay, and your answer is 6.77. I want you to press your calculator. Okay, please make sure you get this value. If you don't get this value, it means you do press a wrong button or you calculate it wrongly. Okay, next, number 2. So number 2 is variance. Okay, sigma square, the formula is summation of fx and then you square the x divided by summation of f minus the mean, then you square it. Okay, so this one is 3 times 4 square, remember you squared the score. Okay, plus 3, 5 square plus 4, 6 square plus 6, 7 square plus 7, 8 square plus 3, 9 square, divide by, okay, 26, and then you minus the mean square, 6.77 square. Okay, press your calculator carefully and your answer is 2.3209. Okay, next the third one, I write it over here. We don't have enough space. So number 3, this standard deviation, just square root the variance. So 2.3209 square root, and you will get 1.523. Okay, so that is how you find the mean, standard deviation and variance for frequency table. Okay, it's straightforward. Okay, so I want you to try yourself number 2, 3, 4, 5 and 6. Okay, just simple as that. Okay, next, okay, let's look at G. Okay, determine the most appropriate dispersion measure to use, either the interquartile range or standard deviation. Then give justification and calculate the value. So this is standard learning standard 8.2.2. Okay, so now let's look at this first example. Okay, given the set of boiling point temperature data for 7 different type of chemical liquid. Okay, so in order to find the interquartile range, you need to make sure your data is in ascending or descending order. Okay, so for this example, it is in ascending order. Okay, and then you find the median, the first quartile and the third quartile. Okay, so I hope you still remember how to find the first quartile and third quartile. Okay, so then, okay, we need to find the interquartile range. Okay, so here, okay, the most appropriate dispersion measure is interquartile range. So you find Q3 minus Q1. Okay, equals to 6. Okay, why do we use interquartile range? Okay, because there is an outlier that is 96. Okay, obviously, tiba-tiba jauh kan 96. The other number are almost the same. Okay, suddenly there are 96. Okay, this is outlier or extreme values. Okay, next let's look at example 2. Okay, the table below shows the score obtained by 2 participants in gymnastics. Who is more consistent? So if there's a question talking about consistency. So you need to use standard deviation. Okay, the smaller the value of the standard deviation, it means the more consistent the value. Okay, so over here we have Alin and Nageshwari. So there are few scores from 5 jury. Okay, so over here consistent. So the most appropriate dispersion measure is standard deviation, because this is a comparison data between 2 data set. Okay, so over here if you want to compare and consistency, you want to find which data is more consistent, so the most appropriate is standard deviation. Okay, so how to calculate standard deviation? You need to calculate the mean first, and then the variance, and then you just square root the value of variance, so you get standard deviation. Okay, so now which one is more consistent? Okay, so from these 2 values, okay, you can see that Nageshwari is smaller. The value of the standard deviation is smaller if compared to Alin, right? Okay, so we can say that Nageshwari is more consistent because the standard deviation is smaller. Okay. Okay, now let's look. Okay, let's look at the first question. Okay, the following is a set of test score data in 7 subjects taken by Ideal. Okay, so the question wants us to state, okay, whether interquartile range or standard deviation, right? Okay, so over here we can see it only involve one set of data. So one set of data, so we can use interquartile range. Plus there is an extreme values over here. So the other number are almost the same, but suddenly there are 100 extreme values. So we can use okay, I zoom in. Okay, we can use interquartile range, okay, because there is an outlier of 100. Okay, so we need to calculate what is Q1 first quartile, and then what is third quartile, and then we calculate interquartile range. Okay, so first of all, we need to make sure that this data is in ascending order. Okay, so yes, it's in ascending order, and then we need to find the median. Okay, we use this method from left to right. Okay, 1, 2, 3. Okay, so this one left, so this is the median. Next, you take a look at the left and the right side, find its median. Okay, so for the left part, okay, the median is 62, so this is first quartile. And then for the right side, the median, the middle part is 71, so this is third quartile. Okay, so we have Q1 is 62, Q3 is 71. So interquartile range, just simply Q3 minus Q1. Okay, so we have 71 minus 62, your answer is 9. Okay. Okay, we can try number 2, the same method. Okay, number 3 also the same thing. Okay, it's a clue for you. Okay, so next let's look at number 4, 5 and 6. Okay, over here we can see that there are more than one set of data, so we know that it should be standard deviation maybe. Okay, so let's look at number 4. Okay, in the 100-meter sprint, okay, Bruce clocked 12.5 second, 12.7 second, 13.0 second, and 12.6 second. While David recorded a time of 12.2 second, 13.1 second, 12.3 second, and 13.3 second. Which runner is more consistent? So over here we can see that obviously it is about consistent. Okay, consistent. And then there are two sets, Bruce and David. So obviously we need to use, what do we need to use? Standard deviation. Okay, so we can say that appropriate measure is standard deviation. Okay, because this is a comparison between two sprinters. Okay, so the first one we calculate Bruce. Okay, so for Bruce, okay, we need to calculate the mean. So mean okay, we have 12.5 plus 12.7 plus 13 plus 12.6 divide by 4. So press your calculator, you will get 12.7. Okay, and then we calculate the value of standard deviation, okay, which is the square root of the variance. Okay, so the variance is, we have 12.5 square plus 12.7 square plus 13.0 square plus 12.6 square divide by, I think we should do it one by one. Okay, I'm afraid that later you will do a silly mistake, okay, careless mistake. Okay, so we calculate one by one. Okay, so square variance, okay, 12.5 square plus 12.7 square plus 13 square plus 12.6 square divide by 4 minus the mean square. Okay, so press your calculator carefully and you will get 0.035. This is the value of the variance. So for standard deviation, just square root of the variance, so you will get 0.1871. So this is the standard deviation of Bruce. Okay, so how about David? Okay, I do it over here. Okay, so for David, we have, okay, for the mean, 12.2 plus 13.1 plus 12.3 plus 13.3 divide by 4. Okay, so press your calculator, you will get 12.725. Okay, next calculate the variance. Okay, 12.2 square plus 13.1 square plus 12.3 square plus 13.3 square divide by 4 minus the mean square. Okay, press your calculator carefully and your answer is 0.2319. So your standard deviation, okay, square root your variance and you will get 0.4815. Okay, so from these two value over here, okay, you have two standard deviation. So which one is more consistent? Okay, obviously we need to pick the smaller variance. Okay, sorry, the smaller standard deviation. So we can say that hence, okay, who is more consistent? Bruce. Okay, Bruce is more consistent because he has a smaller standard deviation. Okay, macam tu je, senang kan? Okay, so when you try yourself, number 5, number 6. Okay, senang saja. Okay, next, okay, we learn how to draw or how to read, how to interpret a box plot. Okay, so H, okay, construct a box plot for each of the following data set. Okay, this is learning standard 8.2.3. Okay, so you have this data. Okay, so you need to arrange it in ascending order or descending. Okay, you list it out. Okay, and then you need to find 5 things. Okay, 1, 2, 3, 4, 5. Okay, where the first one you need to find the minimum value. Minimum value, obviously the first one. Okay, maximum value, obviously the last one. Okay, and then you need to find the median. Okay, so we need to calculate how many one. We can use the method we used previous. Okay, cancel 1, 2, 3, 4, 5, 6, 7, 8. Okay, correct. 9. So this is the middle. So 4 plus 5 divided by 2 is 4.5. So correct, the median. Okay, and then this is the median, right? So let's look at the left part. Find its median. Okay, find the middle part. So the middle part is 1, 2, 3, 4. Okay, you left out with 2. So that's why the first quartile is 2. And then for the right part, okay, 1, 2, 3, 4, and you left out with the single number. So that's why the third quartile is 7. Okay, so and then you need to draw it like this. Okay, so for the minimum value, okay, you draw a dot over here. Okay, I'm using pink one. Okay, dot over here. Okay, and then the maximum is 9, right? So you draw a dot over here. Okay, and then for first quartile is 2. So you draw a dot over here on top of 2. Then the median is 4.5. You draw a dot over there. And then third quartile is 7. You draw a dot. Okay, and then you need to connect Q1 and Q3. Okay, so you draw a box. Okay, like this. Okay, and then you need to mark the median like that. Okay, so you know that the first mark is first quartile, then median, and then third quartile. And then for minimum and maximum value, you need to connect the dot. So you need to draw a line. So finish. This is what we call box plot. Or before this, we call it whisker something lah. I forgot already. Box and whisker, something like that, because this is box and this is whisker. Misai macam misai kucing tu. Okay, so let's do together question number 1. Okay, so first of all, you need to arrange it in ascending order. Okay, so we have 20, 20, 20, 20, 21, 21, 21, 23, 23, 24, 24, 24, 3 times, 25, 25, 25, 26, 26, 27, 27, 28, 28, 28. There's a lot of number. Okay, so let's calculate how many. 2, 4, 6, 8, 10. 22. So 22. So we need to divide, find the median. So 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this is the median. So 24 plus 24 divided by 2 is 24. So median is 24. And then we need to find the first quartile. So first quartile 11. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is the middle one. So 21. So the same thing over here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is the middle one. So that is third quartile. So maximum value is 28. Minimum value of the data is 20. Okay, so let's draw a box plot. Okay, so we have 20 over here, 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay, I use pink color. So 20 is the minimum. Okay, you draw a dot over there. Maximum is 28, a dot over there. First quartile is 21, a dot on 21. Median is 24. Third quartile is 26. Okay, and then you connect, okay, this part. Okay, and then you mark the first quartile, the median, and the third quartile, and then you connect the box. Okay, actually you don't have to do it, it's so big. Okay, you need to draw it smaller. Okay, for example, just like this. Okay, 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 so settle your box plot. Okay. Okay, so next question. Okay, number 2, you can try it yourself. Okay, just simple task. Okay, to draw box plot. Okay, next. Okay, when you have a box plot, okay, you need to interpret the box plot. Okay, so let's look over here. Okay, so this is the thing that you need to find. Okay, so we do together number 1. So we want minimum value. So minimum value is the most left one, so 15. Okay, and then we find maximum value, the most right. This is 40. Okay, 35, 36, 37, 38, 39, 40, 41, 42, 43, 43.5. Okay, so 43.5 is the maximum value, and then we need to find first quartile, median, and third quartile. Okay, so first quartile is this one, 15, 16, 17, 18, 18.5. Okay, so 18.5. Median is 25. And third quartile is 30, 31, 32, 33. Okay. Please make sure you know how to read the grid. You're from 4 already. No excuses. You don't know how to read the grid. Okay. Next, okay, we need to find the range. Okay, so the range is highest value, max minus min value. So max is 43.5, min is 15. So you will get 28.5. Okay, next we need to calculate the interquartile range. So interquartile range is Q3 minus Q1. So Q3 is 33 minus Q1 is 18.5, and your answer is 14.5. Okay, so you can do the same for question number 2. Okay, so I think that's all for today's class. Okay, because we only have a short 2 period, 1 hour today, so we can only cover a few things today. Okay, so you learn about how to calculate the mean, okay, variance, standard deviation, okay, and then you learn about which dispersion is appropriate for certain type of data. Okay, and then you learn how to draw a box plot. Okay, simple one. And then you learn how to interpret data from the box plot. Okay, so there are a few things you have learned today. So I hope you can digest this information properly. Okay, you can rewind and rewatch this video if you quite don't understand. Okay, so I think that's all for today. So next week we're going to continue on the effect of the data if you if you change the dispersion. Okay, maybe you add something or you minus something from the original data. Okay, so that's all for today. If you have any question, you can put it down below. You can write it in the comment section, or you can just ask me in the Telegram group. Okay, so I think that's all for today. Thank you very much for your attention. Okay, see you next class.